Hello everyone, in this video I'm going to discuss panel models. And we know that panel models are important because it allows us to capture the things that change over time and is common to all cross sections. With this one we call it time fixed effects, and it also allows us to capture the things that are unique to each cross section and do not change over time, and we call this one cross section fixed effects. And some textbooks they actually call cross section like entity fixed effect, and the entity could be like a country, could be a student, could be a state, anything. And an example of the cross section is like culture. So culture is basically something that is unique to each country and does not change very much over time. An example of the time effect would be the Fed decision to increase the money supply, and this is something that is common to all states. It's going to happen to all states, and it changes over time, whether money supply, interest rate, anything. Okay, any variable. You can think of the financial crisis. It's also another example that is changing over time, and it's common to all entities or common to all cross sections. In order to capture these effects, we have so many different ways, as you can read in the textbook or on the slides. We have so many different ways of estimating the cross section and the time fixed effects. In this video, I'm going to focus on adding dummies. And adding dummies are used in order to capture either entity fixed effects or the time fixed effects. So, for example, if we have 3 states over 5 years, then we're going to add, this is going to be the cross-section fixed effect, and in order to capture it, we're going to have dummy that is equal to 1, dummy 2, dummy 3. This dummy is equal to 1 if the state is 1, and it's going to be 0 otherwise. This dummy is going to take 1 if the state is number 2 and it's 0 otherwise, and this one is going to take 1 if the state is 3 and it's going to be 0 otherwise. And then we have 5 years, so we need to capture this, and we use time fixed effects with the same idea. So if I have 5, then I'm going to have T1, T2, D1, D2, D3, D4, and D5, and those are going to capture the time effect. Okay, and just to make sure that we can differentiate between the D's of the cross section and the D's of the year, so let me here have I sub I sub I sub I, and this I is simply saying that, for example, this D1I is going to be 1 if I is equal to 1 or state 1, and this D2I is going to be equal to 1 if I is equal to state 2, and D3I is going to be equal to 1 if I is equal to state 3. And let me add here T. So the T here stands for the time or the year, and you follow the same logic. So let me just give you an example of the one of them. So D4T is going to be equal to 1 if we are talking about year 4 or the 4th year we have on the list, and it's going to be 0 otherwise. And this one is going to be 1. You can actually say it's going to be 1 if T is equal to 4. So in order to capture that, as you can see, we have 3 states or 3 dummies for it, 5 years, so we have 5 dummies for it. So a model would look, a model would look like this. YIT is equal to beta naught plus beta 1 XIT plus, going to have a set of n minus 1 dummies. So we're going to remove one of the dummies to avoid multicollinearity with the intercept. We're going to have t minus 1 dummies to avoid again multicollinearity with the intercept. So we're going to start with, let me call this one as delta 2 d 2 I plus delta 3 d 3 I and plus delta. Okay, so we actually I'm going to change this to another letter, and then we're going to add the dummies for the time. So let me use lambda, so it's going to be like lambda 2 d 2 t, and we keep going until the very last year, which is going to be lambda 5 d 5 t, and we're going to have an error term as usual. Okay, so what we have here is we have a dummy for state number 2, state number 3, a dummy for the years, the second year, the third year, the fourth year, and the fifth year. Okay, and we have the intercept. So if I ask you what is the cross-section fixed effect of state 1 and year 1, then it's simply going to be beta node. If I ask you what is the cross-section fixed effect of state 2 and year 2, then it's going to be beta node plus, this is for state 2 and this is for time 2, so it's going to be delta 2 plus lambda 2, and so on. So we have different combinations depending on which state and which year we're talking about. And remember, this is a way of adding a dummy, which is n minus 1, t minus 1, and an intercept. Okay, you can actually add a dummy for the first year and the first state, but in that situation we have to remove the intercept. So if you go with the other option, then make sure that you are removing the intercept and then adding delta 1 d1 here and adding lambda 1 d1t here. Okay, but I prefer to always keep an intercept in my model, and I prefer to have it like in this format. Let me just finish this by asking the last question here. What's the cross-section fixed effect of state, let's say state n, we have here n is equal to 3, so state 3, and let me just choose anything, year 4. So in this situation it's going to be equal to beta node plus, this is for state 3, so delta 3 plus year 4 is going to be lambda 4. Okay, you can have actually a question, you don't have to specify which cross-section and which time effect, but you can do an F-test on whether the list of dummies up to here, whether the list of dummies are statistically significant or not. So we can do an F-test, right? So if I'm asking you whether the list of dummies are equal to 0 or not, then you're going to do an F-test on this one, and everything that you see related to the dummies of the time and the dummies of the cross-section. We can also have a question about whether the cross-section are statistically significant or not. Then in this situation, we're going to do an F-test on only these two. We can have a question on only the time effects, so it's going to be lambda 2 all the way up to lambda 5. So different combinations of different tests that can be done. So in the next video, I'm going to discuss an example on the fatality rate. So I'm going to be talking about the number of deaths on a highway, which is the fatality rate, and how this number of deaths is affected by a list of factors. And this list, one of the important factors we're going to talk about is beta 1 beer tax. Okay, we're also going to be talking about beta 2 unemployment rate plus beta 3 per capita income. Okay, so per capita income, and of course we have an error term for this regression. So we're going to be estimating this model, and this model is going to be starting from the 1982 all the way to 1988, and it's for 48 states. So I'm going to show you in the next video how to estimate this using state. Before you start, you need to determine how many T's you have. Remember, this is, you keep counting, like you have to count 82 because you would have a dummy for 82, okay? Or its dummy can be captured in the intercept. So when you count the number of years here, it's going to be 7, and n here, which is the number of states, is equal to 48. And remember all the time not to forget the sub-index IT, because this one is moving over state and over time. So we have IT under each of these variables. And I goes from the first state all the way to 48, and the time starts from 1 all the way to 7. Okay, and before we start, you need always to have some expectations about the sign of this relationship. I'm just writing positive just as like default how we always write the model, but after you estimate, you would have some prediction on the sign. So we would expect that the higher the taxes on the cans of beer, the lower is the fatality rate. This is like what we would expect. So we would expect this one to be negative. Unemployment rate, we would expect that the higher the unemployment rate, so people are like staying in their house, so there is no density on the roads. So you would expect that the higher the unemployment rate, the lower is the fatality rate. We'd expect this one negative. The higher the per capita income, would expect this to mean that you have a lower fatality rate. So we will see that how these signs are as predicted or not.